Hello, my name is Rebecca Lim, and I'm going to be answering Exam 5 Prompt 1A today. Today, I'm going to be talking about phylogenetic trees. Phylogenetic trees are used to tell a story over time, sort of like how a graph shows the relationship between two things over a period of time. Except in this case, we're exploring the relationship of when organisms emerged. It's helpful to think of a phylogenetic tree in terms of an actual tree. In my example, I'm going to be using different types of shoes, which of course will represent different organisms. In the same way a tree has a main trunk where many branches come off from, a phylogenetic tree has points in the graph, or the actual diagram of the tree, where organisms share a common ancestry and branch off as different organisms, or in this case, shoes. Let me show you what I mean. This is what a real phylogenetic tree should look like. There are lines connecting organisms to each other, all leading back to common ancestors. The elongated lines with no break or branching are an example of anagenesis, or continuous change over time without interruption to that continuous change. The point at which there is branching off is an example of cladogenesis, which is when the branches evolve separately from each other, leading to biological diversity, since more species exist at the same time. At certain points in time, there was either the loss or gain of a characteristic that distinguished one group of organisms over the other. For example, the loss of shoelaces distinguished the entire group of shoes from skater shoes and athletic shoes. And within that category, the addition of height separates wedges and heels from the rest of the shoes. The point at which a branch occurs is called an internal node, which distinguishes the existence of a most recent common ancestor. What determines the orientation or placement of these shoes or organisms are that there are differences in DNA sequences, or OTUs, which also means operational taxonomic units. OTUs can also include different strains of a virus or different alleles within the same species. Some organisms are closer in relation with each other than others. So sandals and strappy shoes are a lot more closely related than the way that sandals and flats are related, which would mean that the OTU between the strappy shoes and the sandals would be a smaller number than the OTUs between the sandals and the flats. There is one organism or shoe, however, that is much different from the rest of the shoes, and that is the outgroup. An outgroup, in our case, slippers, are an organism that diverged earlier than the rest of the shoes. The presence of an outgroup roots the tree in a sense where all other organisms can be traced back to the common ancestor that the outgroup derived from. As the outgroup roots the tree, the phylogenetic tree is described as a rooted tree, where the distance between OTU is known and the order of divergence is inferred by comparing to an OTU that is considered an outgroup. And so the outgroup is most likely the first thing that diverged off from the rest of the population or of the shoes, and that helps to track back down to the main common ancestor where the first split